So now I will say good morning. Okay. So good morning, all of you.
Good morning, ma'am.
Thank you. So this is where we have to begin. I said we will redo it because we were halfway of this slide. Remember, Sahib? I think you were doing the reading yesterday,
Yes, ma'am.
right? Yeah. So can you begin?
Yeah.
And
Acceleration due to.
just a moment, Sahib. Okay.
Okay,
And
ma'am.
rest of you, even you also included, Sahib, and along with the rest of you, if you can understand whatever you're reading, you can speak up. You can define that to me as well or to the class. I'm giving you this freedom.
Sure, ma'am.
If you
Thank you.
understand, you can explain that as well. Okay? All of you, I'm talking to all of you.
Sure, ma'am. Okay.
Thank you. Thank you. Okay, start.
Acceleration due to gravity G. Acceleration due to gravity is defined as the uniform acceleration produced in a freely falling body due to gravitational force of the Earth.
Okay.
Acceleration
Yes, continue.
acceleration due to gravity G is equal to 9.8 meter per second is equal to 980 centimeter
No,
per second
you did wrong. You did wrong. It is 9.8 meter per second square
per second
per
square
second. Yes.
is equal to 980 centimeter per
Because
second square.
meter per second is for velocity. The unit meter
Okay.
per second is for velocity. You
Okay.
understand? The
Yes.
meter per second square is for acceleration. That is the difference. Got it? So we have to be careful
Okay,
regarding the units.
okay, ma'am.
Now, if I ask you why 9.8 has become 980, what you will say?
Because we have converted it in a conversion. We share in maths. We have to convert it into the smallest form, right?
So, 1 meter is equal to how many centimeter?
100 centimeter,
How many? 100.
100 centimeter.
So, what I've done, I've multiplied with 100. So, 9.8 into 100. How many zeros I will have? 9 and 0. And where is the decimal? Zero point 0.8. So, here I will get the decimal. So, it will be 980. You understand?
Yes,
Okay?
ma'am.
Fine. So, this much all of you understood better? Boys, Jishan,
Yes, ma'am.
Naheem, Moin, all of you
Yes,
understood?
ma'am.
Okay, fine. Now we start how to calculate the acceleration due to gravity G. Start.
Calculation of acceleration due to gravity G. Suppose a body of mass m, small m, is placed on the earth of mass capital M and radius capital R. According to Newton's universal law of gravitation, force exerted by the earth on the body is given by capital F is equal to G capital M into small m upon R square.
Okay, this is
Which
what we
is-
studied yesterday. F is equal G mm upon R square. This is what we studied yesterday.
Yes, ma'am.
Yes, fine. So you all know about this formula. Okay. So this is the universal formula and moreover Newton's universal law of gravitation. Let's start.
The force exerted by the earth produces an acceleration on the body. Therefore, capital F is equal to mg, capital small g acceleration due to gravity. From the two equations we have small we have mg is equal to capital G capital M
Yes.
into small m upon r square or G
Doing
is
fine,
equal
doing
to
fine. Hmm.
capital Gm upon r square.
Okay. Now what we did, see, we know F is equal to this is first equation and this is second equation. Now we are equating first and second because see F is equal to this much, F is equal to this much. So what we will do? We will take these two now. Gmm upon R square is equal to mg. So this is what we did. You agree with me? All of you?
Yes, ma'am.
Fine. So you understood? Now we are equating it. What we will do? M cancel, M cancel. Yes, cancel MM on both the sides. Can we do that? Hello, boys, can you hear me? Hello.
Yes.
Yes, okay. So we can cancel M from both the sides. What will remaining? What will remaining? Small g, you can see small g, capital M upon R square, R square. This is what we got the formula as. And this is what you have to remember. G is the acceleration due to gravity. So you have to remember this formula. G is equal to acceleration due to gravity is equal to universal constant, gravitational universal constant is capital G, mass of the earth is capital M upon the distance between the earth and the sun, that is, or earth or the moon, that is R square. Is it clear? So we have come to know about the equation, how we got it, how we derived it. Yes, Sahil?
Yes, ma'am.
Yes. So all of you understood this equation?
Yeah.
Okay. Same thing, huh? We are doing the same thing but in a different manner. Who will take up this? Jishan?
Let me take this, ma'am.
What happened?
I mean, I'm
What
taking
happened?
the same
Okay, fine. Continue.
expression for acceleration due to gravity g. Let the mass of the object put under the free fall is equal to small m, and the acceleration due to gravity is equal to small g. Therefore, according to Newton's second law of motion, we state that force is product of mass and acceleration. Capital F is equal to m into small m into small g.
Okay, just a moment. Now, what he said, Newton, F is equal to ma, right? Hello? This is Newton's second law, F is equal to ma. But what we are doing right now, now we are working on acceleration due to gravity. So instead of A, we are writing m into g. We should understand why we did mg. Why not ma? Now we are not working on acceleration. We are working on acceleration due to gravity. So acceleration due to gravity is small g. Do you understand now? Hello?
Yes, ma'am.
Okay, fine.
Now,
Then,
according to universal law of gravitation, capital F is equal to capital G m mm upon d square. Thus, from about two expressions, we get where g is a acceleration due to gravity. G is the universal gravitational constant. M is the
constant.
constant. M is the mass of Earth, and d is the distance between object and center of Earth.
So what we'll see? Read.
When objects when object is near the surface of Earth, when an object is near the surface of Earth, the distance between object and the center of the Earth will be equal to the radius of Earth because the distance of object is negligible in comparison of the radius of Earth. Let
Just a
the
moment.
radius of Earth.
Just a moment.
Okay, ma'am.
This is Earth. Okay? And this is the radius of the Earth. Right? I've got an object which is very near to the Earth. Now, if I take the radius of this object, do you think it's going to be very voluminous? No, it's going to be very negligible, isn't it? You may ignore it. What do you say? As compared to Earth, the object radius is negligible. You may as well ignore it. What do you say? Hello? Hello?
Yes, ma'am.
Yeah, you understand what I said just now, all of you?
Yes.
Can all of you hear me? Only I'm getting only one answer. What about rest of you? You're not giving any response. Am I audible to all of you?
Yes, ma'am.
Okay, then please come up with your answers. Not only meant for Shaheen, it's meant for all of you. I would be glad if one by one you give me answer. Okay? Say, ma'am, can I? So I think I will be very happy. Class, is it okay?
Okay, ma'am.
Yes.
So what I said just now, that as compared to Earth, the radius of other object is negligible. Am I right? Because the
Yes.
object is very close to the Earth. Object is very close to the Earth. Or what is actually R? R is this much. This is Moon and this is Earth. So what we do? We join this and this becomes R. Is it clear? Is it clear? Now
Yes,
the
ma'am.
object is very small. Object is very small. This is Earth. An object is very small and it's coming near the Earth. So the radius or the distance between the Earth and the object is almost as the radius of the Earth. We can take it as radius of the Earth because the radius of the object is so small that we can ignore it. You got my point? So at that time, the radius of Earth is equal to, it will be almost equal to R. The distance between the object and the Earth will be the radius of the Earth. You got my point? Because the object is very near to the Earth. Okay, read Sahih.
Yes, ma'am. From where? Okay.
Where you left.
Let the radius. Okay, okay, ma'am. I got it. Let the radius of Earth is equal to capital R. Therefore, after substituting
Substituting. No problem. Go ahead.
capital R at the place of small d, we get G is equal to Gm upon R square.
So
Since
remember here what we used to put? D square, isn't it? So instead of D square, we will put now R square. Okay? Read.
since Earth is not a perfect sphere, rather it has oblique shape. Therefore, radius at the equator is greater than at the poles. Since value of g is reciprocal of the square of radius of Earth, thus the value of g will be greater at the poles and less at the equator. And the value of g will decrease with increase of distance of object from Earth.
What did you understand? Can anyone explain? It's very important. What is the shape of Earth? Can anyone tell me? It's like an orange. It's like this. What do you say?
Yes, ma'am.
Right? See, there's a dip over here at the poles. It is not flat. It is a dip like an orange. Like this at the top, like this over here at the bottom. This is the North Pole and this is the South Pole. Got my point?
Yes, ma'am.
Yes? So, radius equator is more than the poles. What do you say? Because there is a dip over here. So, obviously, the radius will be more over here
Yes,
as compared to
yes,
here.
yes, ma'am.
So, if I say this one is R1 and this one is R2, so R1 is always more than R2. Always. Why? Because at the poles we have a dip. All of you understood?
Yes, ma'am.
One more thing. As you go, as you leave, or you go away from the earth, the value of G will increase or decrease. As you go away from the earth, the value of small g, I'm not talking about the universal constant because universal constant remains the same. So we are not concerned about capital G. What are we concerned about is small g. My question to you is, when you go away from the earth, that means you are in flight or you're going in the space, what will be the gravity?
Yes, it will decrease.
As simple as that. As you go away from the earth,
The gravity
yes,
decrease.
the gravity decreases gradually. Okay, and as you come towards the earth, the
The
force
gravity
of
increases.
gravity increases. These are the small, small concepts that one should know.
Yes, ma'am.
Okay, I hope the things are very clear to you. So this was revision. We have already done, you already read it out yesterday,
Yes, ma'am.
today when we started with the class, and now. So it's thorough. You become thorough with the matter, and you should not go wrong anywhere now. Things become quite clear when you revise it. Let's start. Yes.
Okay, ma'am. Since the value of g does not depend upon the mass or distance of an object, therefore all objects fall over the earth with the same rate. The equations for motion are as follows.
What does it
So, may I
show?
read it?
Just a moment.
Should I
Just a
read
moment.
it?
Just a moment, Shayu. What does it say? Since I'm just underlining it. The value of G does not depend on the mass or distance of an object. What does that suggest? Can anyone? This we have already talked about. What does it suggest? G is not dependent on mass or distance. Why? Can anyone tell me? What is the value of G? It is constant. What is value of G? Just now, Sahim, you read it out. 9.8 meter
9.8 meter
per second square.
per second square. Yes,
It
is equal
never
to
changes. Yes, exactly. Or Newton. 9.8 Newton. Remember?
yes, ma'am.
It never changes. That means what? It does not depend upon mass or distance. Mass could be anything. Distance between two objects could be anything. But the constant remains the same. It is going to be 9.8 and nothing else. Okay? Okay? Hello. Yes? Can you hear me?
Yes, ma'am.
Yeah. Now we are going to see those three equations that we had already derived in the last chapter. Remember? Force, motion. I'm talking motion. In that we had come across all these three equations and how to derive that also we have come to know about. Now read these three equations. The
Okay,
first
ma'am.
equation is,
V V is equal to U plus AT.
remember? Do you remember this equation?
Velocity.
First Newton. First law of motion, Newton. Remember? B is equal to U plus AT. Yes, boys, Jishan.
Yes, ma'am.
Yeah. Do you remember these equations that we had derived earlier from the graph? Remember?
Yes.
Now you remember, right? So we use the graph in motion, the chapter motion. That's number 8. All of you
Hmm.
understood now? Please revise. I
Yes,
tell
ma'am.
you, if you don't revise, you will forget, beta. It's for your own good, I'm asking. Be with me, you will not have any problems. You don't listen to elders, you will burden yourself with problems. So we try to reduce your problems rather. So listen to us. That's all I can say. Okay? Because everything is connected. We are talking about the gravitational force, but it is related to motion. If we do not know all these equations, how can we go ahead? You got my point? Boys, hello. Can you hear me? Hello?
Yes, ma'am.
Yeah. So first equation is final
V is
velocity
equal.
v is equal to initial velocity plus product of acceleration and time. That is the first equation. V is equal to u plus at. Say it twice. Samir, Raheel. Say it twice. V is equal to u plus at.
V is equal to U plus 80. V is equal to U plus 80.
Fine. So that is the first equation. Let's come to the second one.
S is equal to UT plus 1 upon 2 at
You will say
80
half.
square.
Sorry. You say half.
Half. Half. S
Half
is
80
equal to
square.
UT plus half 80 square.
Yes. What is S? Can anyone? What is S? Say, I will ask you any type of question in between. You got to be ready. And you have to be very prompt. As soon as I finish my question, the answer should be ready. For that reason, I'm teaching you this way. You want me to wind it up in just two, three lectures? I can do that as well. Why am I repeating so many slides again and again? You should understand that as well. What do you want? That I should finish the lecture in no time? So I want your attention, the complete attention of yours. Okay? S is distance. What is S? Hello? What is S? Say beta. Hello?
Yes, ma'am.
Yeah, what is S? S is distance. Okay? How to find a distance? This is the formula. What is the next one?
V square is equal to U square plus 2AS.
Again,
V square plus is equal to U square plus 2AS.
everywhere can you see one thing common? U, A, sorry, not U, A and A. Because we are concerned with A, not V and U. Remember that. So main thing is acceleration. Now what are we talking about? Acceleration due to gravity. So instead of A over here, what we will put? Which symbol we will put instead of A? Hello. We will put G. Acceleration due to gravity. All of you understood?
Yes,
Arman?
ma'am.
Okay? Fine. Now read.
Therefore, the equations of motion are also applied to calculate the velocity, distance, et-
Etc.
etc. by replacing small a by small g. After substituting small g at the place of small a, we get above equations as follows.
What is it? If you know the formula, then only you can substitute, isn't it? First, you have to mug up the formula. You have to remember the formula. What are the formulas? B is equal to U plus AT. Now, what it will become? Read. Say, hello.
Yes, ma'am.
Yes, say. I'm waiting for it. I said instead of B is equal to U plus AT, now what will be the equation?
G. V is equal to u plus gt.
That's it. Instead of S is equal to UT plus half AT square, what it will become?
Uh,
S is equal to, yes, please read the equations.
S is equal to ut plus half gt square.
Next,
V square is equal to u square plus 2gs.
now read.
In the calculation, calculation, initial velocity u, final velocity v, time taken t, or distance covered s. The value of g is taken as positive in the case of object moving towards earth and take as negative in the case of object is thrown in opposite direction of
The earth.
the earth.
What does it mean? If this is earth, okay? If the object is moving towards it, what it will be? Positive. G. G will be positive. Okay? Now in the next case, this is earth. If the object is moving away from the earth, G is equal to minus. Any problem? Any problem?
No, ma'am.
Again, you are a cricketer, right? Mhm.
Yes, ma'am.
You are a cricketer.
Yes.
So I can apply this equation on you. You're a batsman or bowler, whatever. Now a ball goes high up in the air. You give a shot, and the ball is rising up in the air. G will be
Yes, ma'am.
negative. G will be negative. After some time, it comes to a standstill, and then it comes down. What do you say?
Yes, ma'am.
Okay. And the fielders are ready to catch you. Catch the ball
Yes.
means you will be out, isn't it?
Mm-hmm.
So you will be caught. You will be, I'm not saying the ball, but you will be caught by the fielders. Now the ball is coming down. G will be positive. Got it? When it is hit by the bat somewhere up in the air, the G is negative. When it starts falling down after coming to a standstill, because it cannot keep on and on going up, it has to stop. And then, with the help of gravity, why it stops? Because the gravity is applied on the ball. The force of gravity is applied on the ball. Otherwise, if there is no force of gravity, it will keep going up in the air. It will not, never come back. It will be lost in the space. But it never happens that way because of the force of gravity by the earth. You understand?
Yes,
So
ma'am.
when it comes down, it is positive. When it goes away from the earth, it is negative. Okay, this slide is okay with all of you?
Yes, ma'am.
Nicely?
Sure, ma'am. Nicely.
Fine, good. The same thing, remember same thing, but with the diagram set is shown over here. Whatever you have done earlier is the same thing with the what I should say, A bit of change. Okay, same thing you will understand it better because you are reading it. Let's start.
Equations of vertical motion under the
So what is
influence
vertical
of
motion? What is vertical motion? There are only two ways. What is vertical motion? Can you see this? 90 degree. What is vertical better?
90 degree.
90 degree. That means it is either going
Yes.
up or it is coming down. What do you say?
Yes, ma'am.
And horizontal motion is this much. Like this way or this way.
This way.
Got it? You should, these are specified, so you should understand what are they trying to convey.
Yes, ma'am.
Small, small things I'm making you understand. That's the reason why I'm stopping you in between. So a body is thrown vertically downward. It is not going up, but it is coming down. Okay. Next.
Let a body be thrown vertically downward with initial velocity u. Let the final velocity of the body after time t be y. T be
V V
uh,
V V
v.
V.
Let h be the height vertical distance covered by the body and g be the acceleration due to the gravity. And the
Fine.
equations of motions are
What is it? What is
v
it?
is equal v is equal to u plus gt.
Just a moment. This was V is equal to U plus AT, right? So what we have done, we have removed A and we have put GT. Any problem? This is okay? Hello? Is it okay? Hello? Is it okay?
Yes, ma'am.
What will be the height? The distance will be the height. What will distance? Height. You see over here? This is coming down. This U, V, height, sorry, acceleration and the height. Yes or no?
Yes, ma'am.
Generally, how do we measure? How do we measure everything? From bottom to top. You said this is how we measure from the earth to top. This is how we measure height. We measure from here to here, isn't it? Yes or no?
Yes, ma'am.
But it is opposite. It is coming down from top. So what it will be? Height minus velocity minus because it's from top. It is coming down. Velocity is also minus. But the gravity should be plus. I don't know why they have shown minus. It should be plus. Gravity should be plus because it is pulled towards the earth, isn't it? The gravity should be plus. Okay? Hello?
Okay, ma'am.
Understand? So in this case, what we had written here, S is equal to ut plus half at square, isn't it? So instead of S, what have we written? H. Instead of A, what we have written? G. That's all. You got the answer? So the
Yes,
next
ma'am.
equation will be H is equal to ut plus half gt square. Let's see the third equation. What is the third equation? V square is equal to u square plus 2as. Instead of a, we have put g. Instead of s, we have put h. Got it? You have got all the three equations. Any problem so far? Any problem? Hello? Hello? Hello.
Yes, ma'am.
Yeah. This first case is thrown vertically downward. It is thrown. That means it has been given a force. Thrown means it has been given a force. The body has been allowed to fall down with a force. Now we see the second parameter, that when a body drops freely, that means no force. Remember that. We talked about the feather and the coin. Remember? And the vacuum was created, and both of them fall with the same rate. Did we see that earlier, yesterday? Yes? Do you remember? Hello? Do you remember that topic of free fall of feather and a coin? When vacuum was created, they reached the ground at the same rate. Do you remember or not?
Yes, ma'am. A beat.
Yeah. Yeah. Why is taking so long? I repeated the answers twice already. Okay, so the first, what we did, we dropped the object with a force. Here, we are dropping it freely. That means we are not applying any force. And let's see what we observe over here. So the equations of motion will be what? Tell me. Tell me what it will be. V is equal to U plus AT, right? That's the first equation. Or rather, we will write GT. Now we know free fall. The initial velocity is 0. Got it? Because I'm holding it with my hand. So initial velocity is 0. And then I leave it, it get the final velocity is V. Any problem?
No, ma'am.
Okay. So V is equal to 0 plus GT. 0 does not have value, so V is equal to GT. This is what we got. Any problem?
No, ma'am.
Next is S is equal to, Thomas mic is on, half AT square. This is the second equation. S is equal to UT plus half AT square. Instead of S, what I will write? H is equal to UT plus half GT square. What do you say? Is it okay? Hello? Is it okay? Then H becomes 0 into T, that becomes 0 plus half GT square. What will the equation? H is equal to 0 plus half GT square. H is equal to half GT square. This is the answer. What do you say? H is equal to half GT square because 0 into T is 0. You got the second equation? Yes? Are you understanding or how I'm deriving it? Hello? Hello?
Yes.
Yes? Did you understand how I'm coming to the conclusion? I'm doing the equations, I'm deriving it. All of you understood?
Yes, ma'am.
If at all you have any problems, you can ask me and I will redo it again. Boys, do you have any problem? I'm
No,
giving you
ma'am.
2 minutes. Okay. Now we come to the third equation.
V square
V square is equal to, say, u square plus 2gh,
2a.
right?
Yes.
Isn't it? So what I will
Yes.
write? V square is equal to 0 square
Ma'am,
plus
time up.
2gh. Okay, just one second, ma'am. So V square is equal to 2gh. So this is what we got. The third equation is. What do you say? Any problem?
Okay. No, ma'am.
Now you know how the derivation have come. So it's written over here. How it came, I showed it to you. The third one we will do it tomorrow. I think next session. Okay. So we did only
Okay, ma'am.
four slides. We did with it. Only four slides from 19 to 23. Not